college there. And today we're going to be working on the locker problem. Did any of you read what the locker problem was about in the pamphlet?
Yeah.
Has anyone heard of the locker problem?
Yeah, I didn't get it right, but
That's okay.
50.
So no one has really heard of it or knows what it is. Okay. Has anyone ever listened to NPR? Car Talk?
Yes.
Okay. Apparently this puzzle, the locker problem, was a puzzler on Car Talk. So that's why I asked if some people have heard of it, because apparently, it's out there. Okay. So this is the statement of the locker problem. Okay. You have to imagine that we're at a school and there's 10,000 lockers. Okay, along the corridor. Okay, and they're numbered 1, 2, 3, all the way up to 10,000. Okay. So what we're gonna, can you guys listen up, please? Okay. What we're gonna do here is we're gonna now take 10,000 students from our school. Okay, and we're gonna make them wear name tags. So we have student number 1, student number 2, student number 3. So we're gonna number the students up to 10,000 as well. Okay. Now each of the students has a job, and the job is this. Okay. Student number 1. Okay, so we start out, all the lockers are closed. Student number 1 is going to walk up and open all of the lockers. Go down one by one. Open, 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 open. Okay? That's student number 1's job. Student number 2's job is to close the 2nd locker, the 4th locker, the 6th locker. Okay? So he closes 2, 4, 6, 8, on and on and on, till he reaches 10,000. Okay? What do we think student number 3's job is going to be? Yeah. Okay? It's going to only, yeah, go ahead.
The multiples of 3?
Yeah. So his job is to go to locker number 3, which is open or close? Open, right? Because student number 1 opened it, so he's going to go to locker number 3 and shut it. Then he's going to go to the next multiple of 3, like you said, which was 6, which is was closed, right? He's going to open it. So he's actually going to, we call it change the state. So if it's closed, he opened it. If it's open, he closes it. He's going to do that for 3, 6, 9, 12, blah, 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 until he reaches 10,000. Then student number 4 is going to come up. He's going to change the state of locker number 4, 8, 12, blah, blah, blah. Same thing, 5th student, till we have all 10,000 students walk the hall. Okay? Do we understand the problem? Are you confused about any?
So number 10,000 is going to go 10,000.
Yeah, what's number 10,000 student's job?
Close the last locker. Close or open.
To close or open the 10,000th locker, depending on how he finds it. Okay? Yeah, so we at least understand the question, right? That's the first step, is do we understand the question? And it seems like you guys got it, right? Okay, so but the question is, that's your problem. Now the question is, we have our 10,000 lockers, we send our 10,000 students, which lockers are open? That's the question.
Which lockers or how many lockers?
Which? I want to know which lockers exactly. Like I want you to say 37 and 364. Those are the 2 lockers that are open. Whatever lockers they are, I want you to, we're going to work through it today. I don't expect you to say, it's this one and that one. Okay? So you said number 1 is open. Okay? Does everyone agree that locker number 1 is going to be open? Okay, how can you be so sure that locker number 1 is definitely open? Go ahead.
Because the first person opens all of them, but the second one goes multiple as a 2, and one is a multiple of 3.
Yeah, so once the second person is gone, the first locker never gets touched again, right? So that sounds like a first locker is open. And we see have pretty good agreement in the classroom that that's a true statement, okay? So I actually have cards, and it looks like we have enough students that we should get into maybe 4 different groups. So if we divide the 4 sort of corners you could move so you're all together within 4 groups. So turn the desk, maybe that would be good. Form a little circle with your.
Well, we're just lay them all down, okay, and then we're all going to, you know,
What's it help us, Brad? No. Well,
so they're all open. So that means number 1 went through, right? So number 1 is not through, is open, all of them.
Alright, 11. Let's do 36. Let's say this out on the ground. She knows I got it.
So everyone's open, right?
Wait, check me.
Okay, so now I'm going to you boys. So all the ones that you have to do.
There, take a copy.
Okay, so then what do we do?
Matter with numbers.
Then,
I never just
okay, so we got
Jackie, these numbers. Yeah, no.
So you're number 1.
okay, then,
Number 1, right?
how about, okay, so now,
they're closed, we need help. All right, let's do all the evenings.
Come on, Tyler, help us.
Yeah, so now and then 54. Just look over.
Okay, guys, all the multiples of 3.
And then 6. Okay, so
Number 3
either
comes
one,
one.
add 6.
Make sure we did everything.
That's what you said. And then
Next.
You guys good? 4,
The third person comes through and does multiples of 3.
4, 8, 12,
So now we have
20.
Yeah, now we do the fourths.
6 with
Alright, 5.
So now we're on the fourths. So that means 4, 8, 12, 16,
10, 15, 20, get 20. You guys got 20, about 30. You didn't do 30, did you?
20. It's got to be different by 4.
That's a good idea. So we're on the, I do this roll. I'm in charge of this.
So
You got this round. 21.
13, over your 5, and
24.
13.
Right?
15.
Okay, so let's think it through. They were all open, then all the evens were closed. Now any multiple of 3 should be open.
Or close.
Yeah, so how do we know
If it's even,
which way we did it?
if it's even, it should be
That is
closed.
19.
No, it should be open. If it's multiple 3 and it's even, it should be open right now.
22.
If it's multiple of 3 and even,
So 6, 12.
You're in this right now.
Okay, so we've done 6.
Take notes,
And we also
because that's
look over that.
6. They are multiple
Okay, so
of
flip
3.
the 6.
And even.
Divide by 6.
So start on the bottom.
60 is a little more.
Yep.
Yeah, because 36, 25. So okay, 6.
And then what's 16? What's 6 plus 16? Is 48. And then 42.
If you're so sure your pattern is right, can you mathematically explain
24,
why?
18.
Okay, so now 5.
You spot the pattern.
So we do 5.
Now we got 7.
Wait,
I don't know if
Nathan, you get 1 through 9. Jackie, you get 10 through 18. Tyler, you get 19 through 27. 28 through 36. So remember your numbers. I got 1 through 9. Flip them all over open. Okay, everybody ready? Alright, multiple of 2. 1, 9, 2, 4, 6, 8.
Okay, so let's do 7.
Alright, doing good. Why is 14? Oh, my bad. Alright, now
Okay, so
3.
there's what? 9? We got 10.
Oh, 29.
And then you're done.
Wait, I'm blanking on the multiple of 3.
You do it wrong. Okay. And then,
Alright, multiple of 4.
then 11.
There's 7, so if you do 8.
You know what that was at?
8. See what shows up.
5.
You got 11.
Everybody else needs to be closer.
12.
6s.
No.
6.
Yeah.
Nope.
7s.
Add 8 to that.
36. Yeah. 36. You have what?
8, 8.
12.
Yeah. Keep going. 32.
9s. Okay, I'm saying here, there is, yeah.
And you're gonna have
11.
13. 13.
12s.
39.
13s. Yup.
And then what's 39?
14s. Yup. Oh, yeah.
9 now is going to be open.
Okay, so I got 13.
16s.
I got 14.
17s.
Let's look right there. Let's see what we see.
18s. Alright.
open and then 2 closed, 1 open. Then we have 4 closed, 1 open.
You just did 18, right? Keep going. Keep going on 9. Yeah. Keep going.
Which one is 56? Okay, so that's 14, right? Number 15.
28.
We're turning less than
Why are we so proud?
45.
Now we're gonna turn it even to
60.
It's because we have
Okay.
Just this row right here.
Now we got 16.
math as a sponsor.
Oh,
there you go. Okay.
Yeah, we just did 10. Close 11.
That was 16, right?
Plenty up here.
34.
And then 2 open.
12 is enclosed.
Okay, keep continuing.
Oh, 17, right? Now 18.
There's only one. All the each
Okay.
number, an even number of others.
And 6.
19.
Okay.
Hold on, let's count the factors. Alright. 4. There's 1, 4.
And what else?
1,
Yeah. Yeah. What else we got? We got.
What's next?
We got 30. What's 30 plus?
There's 1.
Okay. Now we're ready.
Alright.
20.
39 is correct.
25,
We got 21.
36.
1,
That's
2,
Now we're at 22.
Next.
4,
Close 14.
9,
44.
Open 20.
8.
Alright, now. Now.
Right, but it's actually much more.
So if we flip this 3 times, then this will stay open.
25.
I see.
So you don't open, so if it's open.
4 times 4.
6.
Wait, but we can't count 1 through these.
No, because first you open. 1,
Open, close, open,
15 and 16 combined, so 4.
open, close,
So now that's
open, close,
Right, so now the next one is what?
close.
32, everything flips over? You flip over? No, all the backwards. Yeah, because that's 31, 32, 33, 34, 35. Yeah.
Oh, yeah, you could say you're adding 3 and 5 instead of saying what you're saying.
all the time.
No, hold on. Okay, 20. Oh, what, 6? What did you say?
What number are we going, 16?
Wait, what do you like? There's 1,
Okay, so we got 4,
yeah.
9,
Yes, 9,
7, 8.
8,
Yeah.
1, 2, 4, 8.
Oh, the reason why.
What did we just turned 16?
Oh, okay.
17 times 2.
You can't write all the other big numbers when you factor out.
That's how
I got it.
So you get from 1 to 4, you add 3.
So the whole pattern is having her square up.
So you're adding 3. So you go from 7 and 9.
Should be equal.
Oh, there you guys said it.
1,
You guys get what's 2?
So the next one is
9.
the next one.
So
this one where it's
and
open,
then the equal, you have to add.
All the other
yeah,
18 more than 36.
but you can't write these
So you
anymore.
get 81.
Like, you said 1 in the
And what's
beginning.
your
Yeah.
81, and that's at 37.
What's your now?
Oh, then because it's a perfect
What's
square.
Even if he's not changing it. Hold on.
And 0.
We're done.
If you can't write twice, you can't match them.
Well, we got the 1, 4, 9, 16.
We were at 196,
And
right?
I messed up because I had 36.
So we're messed up here.
Yeah.
6.
We can figure it out that way.
Every number has a
I have to count.
because it's true.
That's my favorite reason.
Because we guessed it and checked and it's always true.
What number is that?
No, because they always have to have a matching factor. Like if you're going to divide a number, like 80 or oh like it has to have the same whereas it's time to go.
So it's looking
And
at
it's not like we're making it nine, like you want to write it as 9
We're trying to figure out what yours is.
Who's over there? That makes sense to you, Tyler? Yeah. So, okay.
You could also just go through.
So can you try to explain this to me again?
Okay, so all-purpose squares are going to be open, so like 1, 4, 9, whatever. That's because they have a lot of number of times that they're going to be open. Like this is going to be open 1, 2, and 4. If they all start to close, it'll be the opposite of what it opened, which is open. Ones have like an even amount of factors, so like 2 or 4 times they'll be open, so we'll just get
Can you guys come over and work on this right now?
So we actually need to explain this to the rest of the
You guys figure out where.
you'll be good.
Okay. Yeah. So how do we go from 25? So we have another question after this. Is, what is,
You had to figure out what that
Oh, you have to figure out what that is. So here you have.
And now everything at this point is just gonna flip. Well, no, because it does continue on forever.
Yeah, but it's got
For the week.
That was the idea.
And that eliminates one of the
Because there's no more multiples, so now everything that's out there will just flip over when it comes to that number.
all the perfect squares divisible by 3 would be closed.
It'll
And
show
all
up.
the
So what number did you start reading over? What number was it?
Everyone's sort of in a different.
Halfway.
What number was it? It was, yeah, it would have to be.
We gotta figure out.
At 50 you started.
You can figure that out.
Okay, you guys can stop. We don't
Okay,
have to.
that's it.
one thing
So now what is it? What does it say?
Okay, so now the question I want you to look at is what do those numbers have in common?
5, I was right, 9 to
So the 30 is really what it is.
31 is
Okay, 25.
Three and then five.
Okay, so you're telling me, right, that's absolutely right. So you're telling me how to find them. Now what I want you to look at is, look at those numbers. Now that you have the set of numbers, see if there's anything
I think just one and four.
The
Now how do you
remaining
find
closest
it?
are
Look
open.
and see
Oh my gosh.
See if they can figure it out.
I know, I had the same thing.
No, so you got 25, 36, then.
I know. Doesn't it think they can keep the number?
Write down all the open ones. There's 1, you have 4,
There's something wrong.
9,
I noticed that.
10.
Okay, I got another
I
question.
think so.
We might have made a mistake.
So we know how to get all the square numbers over. What if you want, when you're done, what do you want to do?
Yeah, I see one locker that.
You can decide what students to send out. So you can send
Yeah,
some
this locker actually.
and you can do it, just get off your one opening.
You guys will go back through. You can do that. Let's just look at 10. See about who's gonna actually hit number 10. So number, the first guy opens it, right? Locker number 1 opens it. How about guy number 2?
twice.
Still close it. How about guy number 3?
Doesn't
How about 4? How about 5?
Or then means that no.
6,
4,
7, 8, 9, 10.
Set down 4 and then.
Okay, so I just wanted to, I didn't want to just do trickery and say, oh, sugar.
No, I just
now that you have that, we can do the same thing. I think we can do the same thing. 55 should be close to. Okay, so now your next task is to look at those numbers that are open and see if you can find
And all the others
the
close.
patterns that are going to take it down.
Let's do it 1 to 16. Alright, do it 1 to 16.
Like it,
Come to the power.
2 would be 4. 1 times 6 is 16.
Does everyone in the group hear what this locker is open are?
Biggie, are you stuck?
Maybe you can explain to everyone in your group so everyone is on the
Let's
same
say,
page.
Oh, you can feel a lot better about
That would
that.
make me.
Okay, I'm gonna give you guys a few minutes, but I'll come back.
So 1 is open, 4 is open, and then 9. Can you find
No way.
something that's special?
We got this, we got this. Let's do it. Alright. So flip the 2.
Good job.
Wait, no.
What does 4 have in common with 9? What's 2 times 2? What's 3 times 3?
Alright, so about 1 has no effect.
What do you think the next one is? 2 times 2 was 4, that's okay. 3 times 3 was 4.
I'm from out of state.
I like this.
17, 14.
Just started, you know, 2 weeks
Okay guys, we're actually going to come back together for a second.
Here, play like this. Square, right? Then we would send out the eggs. I'm sure there's a
Yeah, you can stay in your group. Okay, so I think most of you are able now to answer the question, which lockers are open? And I want a sentence. So the lockers that are open blank. What can we say?
Are the perfect squares up to 10,000?
Square root.
Are the numbers. So I hear 2 different things. I heard squares and I hear square roots.
Perfect squares.
Square.
The numbers which are
Whatever, it's still square.
squares. So let's just be explicit. Let's tell me which are the numbers that are open.
1, 4, 9, 16, 25, 36, 49.
Okay, let's stop there. We're not going to 10,000. Okay. So, if you are saying that they are squares, what are we saying? If we want to write an equal sign, what does it mean to be a square?
There are square roots.
Okay, so 4 is what number times 2? 2 squared, right? This is 3 squared, exactly. 4 squared. And what about 1? Is 1 a perfect square? 1 squared, exactly. So all the numbers that are open are the numbers which are squared, okay? That's excellent. So we've reached sort of the first hurdle, okay? But now, of course, mathematicians aren't usually satisfied with just the answer. We always want to know why, okay? And I know your group has kind of figured out the why of this first question, but I don't think these 3 groups have yet. So now this is your task, is to figure out the question of why, Okay? So, okay, so it has to do with, did everyone hear what he just said? It has to do with which people touch the lockers, right? Whichever people touch the lockers, that determines whether it's open or closed. So what we just found out is that these are the guys who are open. And I want you to think about what is it about these numbers that make it so that their lockers are open. That's your next task. Okay? So just talk about it as a group. Try and figure out what is it about these numbers. What do they have in common that make it that their lockers are open? Okay?
Okay, so now, flip the 8 right down to the 8.
I think you have to go through the second one.
Take number
And
4.
then flip the 9.
One is a quad.
And then flip the 12.
But that's gonna affect stuff later now.
I know, but we're just
Oh, I guess that won't affect us, I
And
guess.
then flip the 16.
Only numbers that touch
4,
regular.
8, 9, 12, 16.
1,
Plus
2, and 4.
4.
Silence.
Plus 1.
What about number 9? One number, the only number that touch the
Let's get the number back here.
Wait, 9's the only one that's a square.
what about
No,
9 and 16 are.
all perfect squares.
So they're touched in even number of lines, okay?
1 to 8? Did 8 touch?
All perfect squares.
8 touch?
So what is it about the
And
numbers?
16.
Why is it that
So for the first one,
So wait, let's go out some more cards.
so for
Are we starting?
Here's what we got so far.
So your numbers, your numbers
Child
odd
one.
numbers.
We got this. All perfect squares except for one.
but 16 is a special.
What is it? What does it
16
mean to
was
touch? Why?
2 to the
Wait,
power
why are you doing them all at once?
of 4. That is 1 times 2 times
It's all fixed up.
4 times.
Jack, just flipping him
So
over.
we will end up with how many
It has to do with whether it's touched an odd number of times.
The only numbers
Figure that
that
part
are
out. What is it about the
touching
numbers?
these are
Why does 4
the
Or wait,
touch?
like I said,
Leave us over 20. Oh, yeah,
the
yeah.
multiples that go in it.
The numbers are
Yeah, so we don't have any other ones. Like 16 was a special.
Okay, so you have 4.
49.
Wait, how many numbers
Other
are
numbers that
there?
touch 49 are
49 is
Any other number, even number.
7.
Take out the fours first.
Force.
So 4.
What is it about the odd number? One second.
You got it.
Wait, what numbers are we covering?
Like who's
So
doing
the
what?
other,
Summarize.
I'll do one
so
through
number
15.
16 was touched by 1, then 2,
See, you can put it
then
Yeah,
4,
You do
then 8.
Oh, we're going
Then
to
it's
60.
But these other ones were touched by like
Alright,
23
go up to 15
was
now.
touched by number 1 and touched by
Jack, you'll go to
number 23.
45.
How does a
No,
number
20.
makes
Just two, so even.
Alright, so let's restart at the perfect squares again.
Does that make sense?
No, just get it to perfect squares. Does everyone have the perfect squares?
And what did they touch?
Yeah.
Touched by the
Now
number
let's
that
use
we like.
examples of 4.
No, just put the 4 first.
Was touched by 1,
Yeah,
then
multiples
touched
of 4,
by
right?
3, then 5, then 15.
That would have to be one way of thinking about it. You think about, for example,
Good job.
Our group, these kids figured it out.
Yep. Yep. Multiples of 8.
Kara, these things, they figured it out.
Okay. So 9. Or 9. Yeah. 9.
okay, so three teach touch number, so what is it about? And look at 9.
Multiples of 16.
So what does your dad do?
Wait, no, we gotta do 12.
Oh, this is your dad.
So what do we have to do?
It's an odd number of people that touch.
That's what we have to do 8.
I guess for,
Here's the
Are you good?
But you're not.
I'm good.
Why do you touch number 9? You touch number 9 if you are.
teach them how to use spectroscopy.
No classroom teachers. That's a pretty good deal.
No, you missed it by one. I don't miss the grade.
I know, I'm a teacher.
More people?
And you have to do both, research and teacher.
Are you guys good? Yes.
The numbers that are open.
9.
Right, so you,
No,
the
no,
thing
no,
is,
no.
it matters if you end up open. What we care about is if you end up open. Right? So you want to think about how many times do you get touched if you end up open.
I like
How many times touched?
Well,
Every time you are hit an even 4 times.
Could you tell me
So
where
those are all
the
the
unit,
number of
student
times. So are
union?
all of those
If you head out this door right here, set doors, and then you walk down the small hall.
Okay, look at locker number 1. So that's closed.
I have to meet someone. Oh, maybe you don't need your money.
oh
So
yeah.
let's just look at an example of
Wait,
how
that's
number
screwed
2
up our pads.
is closed, right?
Keep going, keep going.
What have you figured out here?
Okay, so now we want to think about the numbers. Instead of thinking about it as lockers, you kind of said it right here. Which numbers touch, for example,
Going to the rec center.
which
Is that why it's just scheduled?
I need someone so they can
and it would end up closed. Gotta get back over it. 25. So what are 1, 5, and 25?
Go down the hall, walk here.
Back. So I want you to kind of come up with a sentence. The lockers that are open
Okay, so you want the.
She said she's gonna
are
drive.
the lockers that are odd. So see if you can
Oh,
flesh
okay.
that out. In terms of, it has to do with factors. It has to do with factors.
We know,
And you'll just head right there. Let me ask another question. Who is going to touch locker number 5? Cars don't get up here, that's the thing. That's why I was asking if you're Memorial Union or the student rec, because the student recreation facility, there is parking structures. This is Main Street, you can get in here to park.
Okay, guys, let's come back together and hash out what we've been talking about.
Generally walk, I mean, certain people can't drive on campus, but generally you don't see that. Special this one is.
Okay, guys, let's come back together here for a second.
Lemon Street and College.
Okay?
And then that's.
So I think most of you got
Parking
this.
structure.
Okay, I guess my question is,
From the student rec.
what decides whether something is open or closed? What did you guys figure out in your groups? Yeah.
The lockers that are odd have an odd number of factors.
Okay.
Lockers that are open have an odd number of factors.
Okay, so the lockers that are open have an odd number of factors. Is that what, so this is what this group came up with. Is that what you guys ended up
Yes.
discovering at your tables as well? Okay, so let's just be clear. The lockers that are closed, even number of factors. Okay? So to take it one step further, why is it that, so these were the numbers that were open, correct? The lockers that were open. Why is it that these numbers here have an odd number of factors? Let's just look at, say, 16. What are our factors of 16? 1, 2, 4, 8. Okay? Now, does anyone see why I put them like that?
1 times 16 equals 16, 2 times 8 equals 16.
So I just lined up what multiplied together to make. So what goes with this guy?
4.
4. So do you see why this guy ends up having because his partner is himself. Okay? Whereas let's look at a nice, does 20 end up closed? Locker 20? Let's look at the factors of 20.
1, 2, 4, 5.
Okay? All of the factors, open, close, open, close, open, close. Right? Whereas over here, open, close, open, close, open. Okay? So basically the square numbers, these squares, have an odd number of factors because of this guy's factor is himself. Okay? Excellent. Okay? You guys pretty much slam dunked the basic. That's what we call the basic locker problem. Okay? So the next thing we're going to look at is, rather than sending all of our 10,000 people down the ramp, down the hallway, what if the teacher instead is a little bit sinister and says, I want locker number 1 to be open. I want locker number 1 to be open, and I don't want any of those other ones to be open. I want just locker number 1 to be open. Everything else I want to be closed. Okay? The teacher is going to give certain kids the day off. He's going to say, you know what, we don't need you. You can stay home today. We don't need you. You guys need to figure out which students are you going to sort of give the day off, and which students do you need to do the job. Does everyone understand what my new question is now? Okay? Rather than sending all 10,000 down, I'm going to pick and choose who I want to send down. My end result being, I want locker number 1 open and nothing else open. Okay? You can use your locker cards to figure this out. You might want to start again, lining them up, and see if you can figure out who are you going to send down. So that's my next question, okay?
Okay. So let's see. Well, we have to get rid of.
What's the next question?
Come on, we're doing.
How many do you?
I think, is this you guys working on
Yeah.
one open?
How many cards?
That's the question, right? They all start with
Time over.
We're trying to
Pardon?
Yeah, just what you're saying is
You probably want to start with the cards again. It actually makes it.
Oh, so that's your answer.
No, we're
I mean, you don't have to. You can also line up in the middle. Instead of saying something like I can wish that we did for students.
other these people should not
So
be.
what's this, those
This is
Number 1
where
has to be there so
This is
to
when
open
we were going to
everything.
go back and send plates, but we're trying to
To open everything.
we don't send them back around.
But actually is. So,
So my suggestion would be what they're doing.
12 twice.
Have one person in charge of it.
So number 2 has to be there, right?
Yes.
Or your sending
So,
Closes 2, 4, 6.
Oh, and all the multiples are in, so then we flip.
number 3 has to be there.
So what's the next?
Count 4 can
Pretty
go.
much every number affected by
So
this.
4
What's
is
next?
5, yes.
I want to get back to my basics. Suppose you send person
So we can just
4 is dismissed, 6 is
Oh, then you
dismissed.
get 8.
and
Yeah,
7.
Then you affect 8.
Just better.
You affect all the other multiples of 4.
Yeah, let's see, you had 2, then you had 3, right? Okay, but did you flip 6 again? Because,
Just 3 came back through.
yeah, I think you lost track there. You were only flipping the ones that weren't flipped. So
Oh,
start again.
Start again. Start them all, yeah. Go back the other way.
Send person.
You're just doing 1 to 20 this time?
Okay. So the highest one.
So number 1 to 2.
So that happens if
We know number 1
if I
is.
send person 4 once and then send them 100 times later. Those are
Opens.
send person 4 and
So, yeah, one's already gone through it already.
That's what I was thinking, like,
What I would actually also
choose
suggest is have
if we send like all these things,
have another person.
So push 4 up.
5,
So you have
7, all those prime numbers, all the prime numbers pull up things. For this one. No, set number 1, you get them all open, then you get them all closed.
Except this time they started all 3.
Oh, and the 3
Everything starts at
10.
I did it to 10.
So it would be,
You need to send a different amount.
Should we get 10 more? Do 10 more just to see.
if you do the same. But there is a time.
Send anybody you want.
Just to do
Just
the
need to
same.
leave locker number 1 open. Everyone else needs to do it.
Please.
You have to go up to 20.
But I would suggest.
Okay, so
let's
we
keep track of
sent
it.
4, 8, and 9 home.
But we have to restart them because now we
Like, for
don't.
example, we have
So,
number 1.
it's good, okay. Good practice.
You don't solve problems like first time.
I'm talking number 1 to you. Everything starts out closed.
Oh, this is
And then locker number 1, 1 open, everything else. Right, there you go.
Don't be confused. Everything's closed. Right? Everything's closed.
2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6.
Okay.
Everything is closed except for number 1.
Yeah.
Oh,
Everything
yeah,
closed except for number 1.
Yeah.
2,
So,
3,
Close
5,
9, open
6,
12.
7.
right. So do you send down kid number 1?
Because over 10 is
You'll be
equal to
charged
5.
down.
Same line down there.
Right.
So let's try opening them a different
Yeah, 4 we don't
Kid
need.
number 1.
That means 14.
Okay? So I want one of you guys to keep track of what you're going to
Okay, so
send.
1 and 3,
You
right?
guys that you gotta send
So
down.
no reason, yeah.
Send them down the hallway.
So what's
Send
gone
them
down?
down.
What's already gone down? So they're all,
One person
now we're
down,
using
someone
2
else
down.
keep track of what you send.
That means 2.
So one of you send, because we're trying to get.
Or we never sent.
So 2 have 4. No, we're gonna go step by step. Okay, so
We already
so 2 to go through. So all 2 you can go.
9.
4,
5,
Wait, no, we don't have
7, 10. 7. You only left with 10.
Okay, wait. It's okay.
4 first, baby.
Alright.
Now, 3 is open, we gotta close the
Look at 4 twice, but wait, I think it's 10, 4, 3.
Because 3 is open right now, we gotta close it.
How about 12?
So 3 has
1, 3.
6.
So 1, 3, 4.
21.
Who have you sent down?
So now what these numbers have in common with 60?
And then you flip 2.
No, I say no to.
Yeah, 3. And then you have this open. And then you flip 3, close 6, close 9, 4, you close
They went up to
2,
60.
flip 5, you close 10.
Probably
flip
better if
7.
you had 10,000 lockers secured than having one landlord.
If you want.
But exactly what's going to happen now.
No. 7.
It's a good start.
Jackie asked a good question.
Okay.
Doesn't
Yeah.
matter if
You want 4?
Yes.
So
What about first
Wait,
If everybody goes.
Because it's still gonna get, each locker gets changed to the same number of times.
When it's walking.
Okay, so you guys have figured out who you're sending and who you're not sending now?
Well, only up to 20.
Okay, so now, of course, you're looking for, what do you think the pattern is? What do you think the numbers that you sent versus the numbers that weren't sent? So try and look for, is there any pattern,
12.
anything in common? That's your next task. See if you can,
With respect to 60, up to 60.
I mean, up to 10,000, but,
Oh,
yeah.
What do you?
Up to 20, if you don't see it, maybe keep going a little bit more. Maybe you can spot it up to 20.
Now we have to decide, right?
So each, like if you send 4, then 2,
14.
like
21.
Wait, there are no.
Alright. You said 4 first. Wait, let's test this out.
This is 2 squared square times 3.
Alright, so number one just went. Alright, now we're gonna send now we're gonna send.
Oh, yeah, okay, now 10. So
We have to look at the factors. Look at the factors.
Right.
Find all the
It's
factors.
an 8.
The factor of
You sent 4 down first, then 2, then 2.
Okay, now, there's a 1. Yeah, there's an 11. So that's going to go 11 down.
Now we're not doing
the
4.
prime factor.
Right.
Factor of 11.
See,
Factor
why
of
do
that.
Okay.
This was an easy one.
Now, we'll
Write
write
this down.
So do
Alright.
What goes first? We're going to 12.
And then
You
10.
said 13.
Factor of that.
13.
And then 4.
And 5.
Then 2.
Then 3. Then 4.
Now, we next. You got 14.
Then 5. 7 and 10.
Okay, well, I mean, you've got 2 rows there.
But
Now you're just, like I said, it's just start just throwing out options.
No,
Like,
10
it
was
doesn't- what you do, it doesn't matter if they're wrong, right?
Okay, you said 15?
Just state something.
Yeah, you said 15.
Okay, so we know we're going to 10,000, right? So this is basically.
Well, I swear the first time we were all close. That was because we went in a different
This
order.
has
We
to
went in order.
You could have to represent the factors that are going to go all the way up to 10,000.
Yeah, but let's just do them all once.
So you said 17.
Here's why I think it's 2, 3, 4,
All of these
5,
numbers.
6, 7, 10.
Okay, except
So 1, 2, 3, 4.
this one seems to be off, it's not.
1 through
Okay,
7.
this is what's messing up everybody. I'm
Alright,
trying to
so let's do
figure
this
out.
again.
Because look,
Alright, so
You
you
were saying
want to go first.
4 times 12. Okay, there's a factors here.
3.
Is 4 factored here? Okay, but it's not a factor here, right?
5.
Is it factored there? Is it factored there? It's factored there.
Or actually, no 4. It's no 4. Actually,
Okay,
5.
but now, you've
Yeah,
got the
5.
odds.
You said 22. Okay, so you said 22.
6s.
Okay. So now, we've got
You said
7.
factor
You
of
said
4.
23.
Then we also have the perfect square. This is 2 squared.
You said 24.
This is 3
We
squared.
got those numbers now. Alright.
Okay, so now I've got a pattern here. We started out with, alright, our original thing was perfect squares, right? And now we've got perfect squares, 2 squared, and 3 squared. And the original problem was I just wanted the number 1 open.
27. Or 28.
So now my first assumption is I just want 1 open. And of 1 bigger. 2 squared with the factors in that row. So 2 squared is 4. So now you almost.
Okay, so 30.
No, not 8.
You said.
Okay, so that gives me 4.
Right,
Now,
You said 30.
to do.
I took it.
Well, that means everything, all multiples of 4, all factors of 4 from 1 all the way to 10,000, right?
All the way to
Okay.
10. See that?
Okay.
So all factors of 9.
Now we have 3 squared.
36 now.
So all the factors of
Stop. Okay, so no
3 squared from 10,000. But now we have to relate it to see if we
It's good.
can
Which ones don't have?
comprehend y.
When you make this, so that
Does that make sense?
So explain now. Now you
Did
explain.
you guys figure it out?
Yeah, explain
No,
it.
I'm not sure yet.
Is there a pattern in numbers into it?
Well, okay,
That comes next.
okay, so you've taken care of these 2 numbers, right? Okay, and then you've taken care of all their components or their friends higher up, right? Okay, so now you're dealing with these 2 guys. What makes these guys how are you gonna put
One,
that to be
and
original
then I'll
question?
try.
One is not.
Okay, which is, why is,
No, we're doing
okay,
one.
what's the, okay, we figured out factor 2, which is starting out with the original premise of 2 squared. And then the next factor was 3 squared, right? Okay, so in going from 1 to 10, we want locker number 1 open. Okay, so the guys were sent out home for some reason, seems to be 2 squared, 3 squared.
And then let me send that multiples of 9 to 27. So that has to be 2. And then what would come after that?
This one's like this.
Go,
Okay.
yeah.
But
Then
they're
you have
also
to
the
go,
perfect squares. We made it back to the
then you have to
original
go to the next one.
Guys, let's go
But
back to this.
4
You
is
said
not
we
a
were on
prime,
the
so
right
you go to
track.
5.
Yeah.
5 squared is what?
Come on, you guys like.
25 goes to
Learn
5.
anything?
The numbers I circled
What's
have something to do
25
with
times
it.
2?
Because you have to get every bagger up to like.
50 goes, does 50 go home?
Ah.
What, 50
All right, look.
times 3?
Don't break your finger when you use a lot.
Does 150 go home?
Alright, 4, 8,
What comes after
15,
5?
20, 24, all have a common of 4.
No.
12.
You see that?
6 times 6 was already on.
And then these all have
And then 7.
So all multiples of 4
So
is
you go to the prime now.
What's those numbers have in
So
common?
7 times 7 49 goes home. What's 2 times 49?
Maybe later. I don't know how that factors into it.
Goes home and so.
So we have the test, you know, it'd be
So
3.
you take all the prime factors
First off, you
3
gotta
versus 2.
No.
and send them out if you want.
So now we're
Go
going
to
to
10.
These are all the numbers we had to read, like, which one close.
Who have what in common?
Oh, yeah, the,
So we have to flip 3 again?
no, 9.
Alright.
You know where
That
you
is the next section.
Oh,
No, I have to go to each one of them.
5, 2.
Those are the ones that.
I think you have time, right?
That do not go.
2:30 is the next one, isn't it?
Right.
Oh, it's 1, never.
1:30, you're okay.
I was thinking Minnesota.
From Minnesota, huh?
Yeah. So we are starting this kind of circles. Hoping
Yeah,
to
there.
start
I think this
in
is it.
Minnesota.
But you have to flip every multiple of 5, 9, 6, and 4
But this is one of my favorites.
again.
In addition to.
And the prime.
5, 6, 7. Did they miss anything here? How?
7, yeah.
Okay, what was after
10,
11?
11, 13, 14, 15, 17, 19.
Okay, let's stop at 20 just for, okay, so you're sending these guys.
Yeah.
Did the other 2 groups agree? Are you sending these guys down the hall?
Yes.
Okay, so, sending down the hallway. Okay, so, let's just, for, sake, can we name the numbers who we are not sending down the hallway?
That's the bottom of this.
Yeah.
Okay, so you're not sending 4, 8, 9, 12, 16, 18, 20. Okay, let's just stop at 20 since
We're
we
giving
were.
those guys a day off.
Yeah.
Okay, does everyone agree these guys get the day off? Okay, so in our first question, when I said when we send everyone down the hallway, which lockers are open, we had a nice sentence, and our sentence was the squares lockers are open. What we want to do now is, can we come up with a nice sentence in order to leave locker number 1 open? Can we put this long list of numbers into a concise set of words? You see what I'm saying? Like, what is this group of numbers? Or, what is this group of numbers? Did anyone find a pattern within this group of numbers or within this group of numbers? So that we can sort of state it in a precise way. We're sort of looking for the pattern. What do these numbers have in common? do those numbers have in common? I heard some different ideas out there when we were walking around.
The day offs are all multiples of 4 and perfect squares except for 18.
Multiples of 4. Okay, does everyone agree? Does everyone agree that multiples of 4 are in that list?
Yes.
No, except 3.
Some of them.
Multiple of 8, 12,
So we
3.
said multiples of 4 and
3.
multiples of 3? And okay, are all the multiples of 3 in this list?
Yeah.
What?
No.
Can we say multiples of 3 are in this list?
Some
Name,
are.
name me the multiples of 3.
3, 6, 9.
Is 3 in there?
No. 9, 18.
So therefore, these are not the multiples of 3. Are all the multiples of 4 in here? Name me the multiples of 4.
Yeah, 4, 8, 12, 16, and 20 are all in there.
Are they all in there? And they're going to
56 is not.
are they going to keep going in
56
there?
is not.
Yeah, got 9.
We haven't gotten up that high.
Perfect squares times prime.
Okay. I heard multiples of 9, and I'll get to your suggestion in a second. Multiples of 9. Name me the multiples of 9.
Multiples of 5.
Wait, 9, 18. Are they in there?
Yes.
Okay.
Yeah. Just 6. Yeah.
Okay, multiples of 9 are in there.
Multiples of 10.
Not all.
Yeah, there's 20 and 40.
10's not in there.
Yeah.
Okay.
Okay, look.
Wow.
How about this? How about this? I'm going to cross out multiples of 4. 4, 8, 12, 16, 20. I'm going to keep going. 24, 28, 32, 36, 40, 44. Okay. Now you told me multiples of 9. Multiples of 9.
18, 27, 36,
36, 37.
45.
Okay. What else is left in here?
5.
25.
25.
Multiples of
20. Oh! Perfect square. Multiples of perfect squares
okay.
are not being sent out.
Multiples of those, yeah.
Okay. Now we're missing one in there. Our perfect squares are starting out 2 squared, well 1, but we needed to leave locker 1 open, so we had to sort of leave that out. 3 squared. What happened to 4 squared?
2 squared.
4 squared is already here, right? So it sort of got mentioned. Then here is 5 squared. So now we can put our nice little sentence. We are going to send down the multiples
Of prime squares.
of,
Or you're not.
you don't really need the word prime, multiples of squares. Yeah, multiples of squares. I guess, yeah, because you're trying to leave out 1. Is that why you're saying prime squares?
No, I was saying 5 because 2, 3, and 5, you don't want to repeat.
4. I see.
4, 9, 16,
Yeah. I mean, the multiples of 16 are in there, right?
Yeah.
Because it's in there 16 and 32. So, yeah. Okay. So, if these are the multiples of squares, let's just call them the multiples of squares. The guys who get the day off are the multiples of squares. Who are these guys? But how do you think mathematically, if these guys are multiples of squares, these guys are, someone actually said,
Square roots. I'll remember their square roots.
Yeah, all of them.
I'm not following. I'm not following what you said.
He was wrong. Yeah, I was totally wrong. Don't even listen to me. I'm the last person anymore. The world is ending.
Okay, how about thinking about something this way? If you have, all of these cards here are blue, right? That's what all of these cards here in common. So, if I had stacks of other cards that were red and orange and green, if these are all blue, that's what these have in common. What do all the other cards have in common? They're not blue. So if these ones are multiples of squares, these ones are not
two non-multiple squares.
Except for one.
What square makes two?
Yeah. Four. Right, no.
Is everyone with them? Yeah, two is not a multiple of a square. Okay. So, but of course, mathematicians have a lovelier way of saying it. This is a totally precise and correct way of saying it. Rather than being all negative about these students who are going down this hallway, we're going to be positive and frame them in a positive note, and we're going to call them the square free students. Okay? Because there's no squares in them anywhere. Okay? These are the square free students. Okay. All right. So the last thing I want you to look at, the last thing I want you to think about, okay, is we looked at who do we send down the hallway to leave locker number 1 open. Okay? I want to see if you can come up with, rather than keeping locker number 1 open, what if I wanted to keep any number closed? What if I said, how about locker number 23? What if I want to keep locker number 23 open and everything closed?
You don't send down number 1 though.
Okay, you don't send down number 1, exactly, right? Because if you send down 1, what's going to end up open?
One's gonna be open.
So it's a similar problem to keeping locker number 1 open, but this time, can we keep, let's say, locker number 6 open and everything else closed?
Wait, for 25, all you have to do is send down.
Okay?
One, so it's gonna be open. Oh, I got it. You don't send it.
Who can you send if you want it? Looks like we have about 15 minutes left. Okay?
If you wanted locker number 6 open, you could just send out.
Yes.
Oh, you can't just send out the 6 guy, can you? Because that affects all that.
Take like 5 minutes and see what you can come up with. Take like 5 minutes and see if you can come up with who we're going to send down to keep locker number 6 open. Okay? Go back in your room. You just want to keep. See if it works.
Yeah, I know. I'm
So do you guys see what your answer is?
This shit has to be open.
That was what I'm thinking.
Yeah.
Yeah.
We had to declare it.
Right,
And
so
so
you
dad
already
wants
said,
to
you already said. If you said 4 twice, you might as well.
So really,
So you have to say, you didn't have to.
oh, we had the numbers up there. We just weren't finding
Sit
it.
down, choose.
Yeah. You were approaching the problem differently. Starting point.
You have a whole.
Okay, so only keep number 6.
And you said 12. Yeah. Yeah, you just said.
Why don't you just let me die? Open up specifically.
Well, try it.
locker number 6.
See if it works.
Yeah, seriously.
I mean, you can try it on paper if you don't want to deal out the cards
No,
again.
just
Just
send
write out the
that
numbers and see if it actually
locker
works.
number 6. But then he has to open all multiples of 6. You can't just die. You can't just. You have to open all multiples of 6. Well, you're asking me how many do this. How long do you do it?
I mean, like 6, 7, 8, right.
Okay, guys, let's There's actually, this is kind of a handout. There's actually lots more variations on the locker problem, so if you want to take one of these home with you. Basically, the locker problem, you can kind of keep varying it in different ways. Like the one we're working on now is, if I want a particular set of lockers open, who do I send down? The other way of varying it is, say I send down the prime number people, the prime numbered students, which lockers end up being open. So those are the sort of two ways of varying this problem. Which lockers do I want to end up opening, or which students do I want to send down, and just see what happens. So there's lots of different ways you can play with this. Yes?
Is it possible for everything to be, is it possible for, let's say you choose any of the numbers, it's possible to find a way to open that single one?
Yeah, I think so. It might be very difficult to figure out who you're going to send down, but there should be a combination of sending down. Okay? I want to leave it as an open question for people to figure out. Thank you guys. You did an excellent job of figuring this out. If you could just bring the locker cards back up, someone else needs to use